A bee stings you, and then, within minutes, it dies. The weapon it used tears away from its own body as it flies away, taking part of its abdomen with it. The act of stinging is, for the bee, a fatal injury. Most animals, when they use a defensive weapon, survive the encounter and live to defend again another day. The bee does not, and for a long time, this looked like a serious evolutionary mistake, a fatal flaw baked into the design. On paper, a defense system that destroys the defender should have been eliminated by natural selection long ago. An animal that dies every time it defends itself has a serious survival problem. But the bee is still here. 100 million years of evolution kept this system exactly as it is, unchanged, unmodified, unimproved, which means the death is not a flaw that evolution failed to fix. The death is the feature that evolution chose to keep. To understand why, you need to understand what the stinger actually is, what it was originally built for, and why it behaves completely differently in mammal skin than in anything else the bee was likely to encounter across most of its evolutionary history. The honeybee stinger is barbed along its length. Small backward-facing hooks are built into the structure. When the stinger enters soft tissue and the bee tries to pull away, the barbs catch and hold. The stinger tears free from the bee's abdomen, taking the venom sac and part of the bee's digestive system with it. The bee flies away. It is already mortally wounded. It will die within minutes, sometimes within seconds, from the internal damage of losing part of its body. Now, here is where most people stop asking questions. The bee stung. The bee died. It hurts. Story over. But the story has barely started, because the stinger that was left behind is not inert. It is not just sitting there. It is still actively working without the bee, without any continued input from anything alive. The stinger is attached to a venom sac with its own muscular pump. When the stinger tears free from the bee, the pump keeps contracting. It continues pumping venom into the wound for up to a minute after the bee is gone. This means the bee doesn't need to be there to complete the sting. The venom delivery continues after the bee's death, automatically, mechanically, without any further involvement from the animal that deployed it. But the venom is only part of what the stinger is releasing. Alongside the venom, the sac is also releasing something else, a chemical signal that travels through the air and that every bee within range is built to detect immediately, an alarm pheromone. That pheromone has a scent profile the colony recognizes immediately. It smells like banana, if you're curious. And to a honeybee, it means one thing: the hive is under attack. Come here, sting this. The dead bee has just called in reinforcements from beyond its own death. It did not survive the encounter. It cannot sting again, cannot communicate, cannot do anything further. But it left behind a system that will continue the defense without it, automatically, for as long as the stinger remains in the skin. This is why you should remove a bee stinger as quickly as possible. Every second it remains in your skin, the pump is delivering more venom and broadcasting more alarm pheromone. Scratching at it makes it worse. That spreads the pheromone and drives the stinger deeper. Now, the critical question. Wasps also sting. So do hornets. Their stingers are smooth, not barbed. They can withdraw after stinging, and sting again multiple times. Why did honeybees evolve a barbed stinger that kills them, while their close relatives did not? The answer is that the barbed stinger was not evolved for use against mammals at all. It was evolved for use against other insects, against rival bees, beetle larvae, other colony invaders. In insect exoskeleton, the barbs don't catch. The stinger can be inserted and withdrawn cleanly. Against another insect, the barbed stinger works exactly as designed, and the bee survives. Mammal's skin is the problem. It's thick, elastic, and it grips the barbs as the bee tries to pull back. The same elasticity that makes skin so good at healing wounds makes it catastrophic for the bee trying to withdraw. The bee's stinger was never designed for something like us. We are an accident of context. But when a large mammal, a bear, a badger, a human threatens the hive, the bee stings anyway. And what happens next is the system adapting to a situation it wasn't designed for and producing a better outcome than the original design. Against a large mammal, a single sting from a single bee barely registers. The mammal could push through it, destroy the hive, eat the honey, and walk away. The bee dying after one sting on its own would be pointless. But the stinger stays in the bear. The pump keeps going. The alarm pheromone spreads, and within seconds, dozens of bees are orienting toward the same point, the same smell, the same target. Each new bee that stings adds its own stinger, its own venom pump, its own pheromone signal. The alarm compounds, the recruitment cascades. What started as one sacrifice becomes a coordinated defense of dozens, then hundreds. The first bee to sting didn't just deliver a dose of venom. It lit a signal flare that will continue broadcasting for up to a minute after the bee itself is gone. It marked the exact location of the threat for every defender in the colony. Its death was the broadcast, and the broadcast continues without it. This is not individual behavior. This is colonial behavior, a distributed defense system where the unit natural selection is actually operating on is not the bee, but the colony. The bee is a cell in a larger organism. The colony is the organism, and the defense was designed for the organism, not the cell. A single worker bee, on its own, has almost no reproductive future. It will never lay fertilized eggs. Its genetic legacy passes through the queen, through the survival of the colony. Its own death, if it serves the colony, is not a loss. From the colony's perspective, from the perspective of the organism that natural selection is actually acting on, the barbed stinger is a perfect design. The individual bee is expendable. The colony is not. Think about how different this is from the way we usually think about animal instinct. We imagine animals acting to preserve themselves, but the bee acts to preserve the structure it belongs to, because in evolutionary terms, that structure is what it actually is. There is something in this that's harder to shake than the mechanism itself. The bee doesn't hesitate. It doesn't calculate odds. When the colony is threatened, it responds, and the response it has available costs it everything. The next time a bee lands on you, before you swat at it, notice that it isn't stinging you. A bee that isn't threatened won't sting. It has too much to lose. It will only sting when it believes it has no choice. When it does sting, it is committing the only thing it has, its entire life, its entire body, to a defense it believes is necessary. The sting is the bee's whole existence, spent in a single moment for the thing it belongs to, and then it's gone. A bee sting hurts. That's the point, and that is entirely by design. You'll remember it. You'll move away from the hive. You'll give it more space next time. The bee is gone, but its message was delivered with enough force that it will last. A dead bee with a lasting deterrent is worth more to the colony than a living bee who failed to deter. The bee that stings you is not attacking you. It is making the only move available to it when it believes its colony is in danger. It dies doing exactly what it was built to do, and it works. If this changed how you see the next bee that lands near you, if you'll give it a second before you move, subscribe. We keep pulling apart the hidden systems behind the wild. The wild mind is everywhere around us. Keep looking. I'll see you next time.